Hello everyone. Today we're going on an incredible journey not just through space but also through time. We're diving deep into one of the most fascinating discoveries of our era, the asteroid Bennu. What makes Bennu so special? Well, it's not just another chunk of rock floating through the cosmos. Bennu might be a fragment of an ancient world, a lost planet that once had oceans, maybe even the building blocks of life. So grab a cozy spot, settle in, and let's explore this mystery together. Imagine this. It's the 1960s and 70s. The Apollo missions are the talk of the world. Brave astronauts are venturing into the unknown, bringing back rocks and dust from the moon. Those samples were priceless. They gave us a glimpse into a world beyond our own. But since then, only a handful of missions have succeeded in bringing samples back to Earth from other celestial bodies. Most of these missions focused on much smaller objects than the moon, mainly asteroids. And Bennu is one of those asteroids. Bennu was not always seen as special. For a long time, astronomers considered it just another ordinary asteroid. They expected to find the usual round mineral formations, known as chondrules, which are common in many asteroids and meteorites. These chondrules are like tiny grains that might have formed billions of years ago when the solar system was still young. Back then, the intense heat from the sun could have melted minerals, which then cooled and formed these little round shapes. But when NASA's OSIRIS-REx mission got up close to Bennu, it was a whole different story. Instead of those familiar chondrules, Bennu's rocks showed signs of a much more dynamic history. It was as if Bennu had experienced something extraordinary, something that had chemically transformed its rocks. Scientists quickly zeroed in on a likely suspect: water. Water is a game changer. When rocks interact with water, their mineral structures can change dramatically, and Bennu's samples showed undeniable signs of water exposure. The evidence wasn't just subtle hints either. The samples contained minerals like phosphates and silicates, which only form in the presence of water. There were also high levels of carbon and nitrogen, two elements that are critical for life. These findings suggest that Bennu might not just be a stray rock in space. It could be a fragment of a much larger planet that once had water, possibly even oceans. This idea opens the door to an even bigger mystery. What if Bennu's parent planet was a place where life could have begun? The samples contained 14 of the 20 amino acids that make up proteins in living organisms. Amino acids are like tiny Lego pieces. When you connect them in the right way, you get proteins, the building blocks of life. And finding so many different types of amino acids on Bennu is a big deal. It suggests that life's raw materials might not be unique to Earth. But the surprises didn't stop there. The samples also had an abundance of N-heterocycles. These are ring-shaped molecules that play a critical role in forming DNA and RNA, the genetic blueprints of life. Imagine finding puzzle pieces that look just like the ones needed to build life as we know it. The scientists were astonished. All 5 of the nucleobases necessary for DNA and RNA, adenine, guanine, cytosine, thymine, and uracil, were present. This is like finding a cosmic recipe book with all the essential ingredients for life. And there was more. Salt crystals in the samples hinted at an environment that once held salty lakes or oceans. The specific chemical signature of these salts closely matches what we find in salt lakes on Earth, such as those in Australia. This similarity led scientists to theorize that Bennu might be a fragment of a parent planet with briny waters. This parent planet could have been a large protoplanet, or even a dwarf planet that existed billions of years ago. Around 700 million to 2 billion years ago, this planet might have collided with another object in a catastrophic event. The collision shattered the planet, sending fragments like Bennu drifting through our solar system. If Bennu's parent planet had survived, it might have developed life, much like Earth did. Our planet has endured numerous massive impacts over its 4.5 billion year history. Some of those impacts were so powerful that they wiped out entire ecosystems. But unlike Bennu's world, Earth remained intact, allowing life to flourish. As we study Bennu, we're not just learning about an asteroid. We're piecing together the history of a long-lost planet. If that ancient planet had survived, our solar system could look very different today. There might have been two worlds with oceans, two worlds with life, and maybe even two civilizations sharing the same sun. This discovery also raises exciting possibilities for future space missions. If Bennu holds so many secrets, what about other asteroids and comets? Could they also be carrying pieces of ancient worlds or clues to life beyond Earth? The potential is immense. With each new mission, we might uncover more fragments of ancient planets, allowing us to reconstruct the story of our solar system. So, as we hold the tiny grains of dust from Bennu, we're not just looking at an asteroid. We're looking at a piece of a world that might have been. A world that could have had rivers and lakes. A world that might have teemed with the building blocks of life. It's a reminder that our universe is filled with mysteries waiting to be uncovered. And as our technology advances, who knows what incredible discoveries lie ahead. Thank you for joining me on this journey through time and space. Stay curious, keep looking up, and until next time, keep exploring the wonders of our universe.